Hello, this is David Hall, and it is my pleasure to welcome you all to today's webinar, Disrupting Industrial IoT Through Edge Intelligence, presented by the IoT M2M Council and sponsored by Dell Technologies and Telit. Before we begin, we want to cover a few housekeeping items. At the bottom of your screen are multiple application widgets that you can use. All of these widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure that your computer speakers or your headset are turned on and that the volume is up so that you can hear the presenters. If your slides are delayed, pushing F5 on your keyboard will refresh the page. You can find additional answers to some common technical issues located in the Help widget at the bottom of your screen. An on-demand version of the webcast will be available approximately 24 hours after the webcast and can be accessed using the same audience link that was sent to you earlier. If you have any questions during the webcast, you can submit them through the Q&A widget. We will have a Q&A session with our panelists at the end of the presentation, but please feel free to ask questions at any time during the presentation. We will try to get to these during the webcast, but if a fuller answer is needed or if we run out of time, it may be answered later via email. Now it's my pleasure to introduce our moderator, Keith Kreicher, the Executive Director for the IMC. Keith, the floor is yours.
Thanks, David, and thanks to everyone for being here. Certainly like to start off by saying I'm hoping everyone attending is keeping safe and well. It's a difficult time in the U.S. and across the world, so we do appreciate you being here. Welcome to this webinar, Disrupting Industrial IoT Through Edge Intelligence, brought to you by Dell, Telit, and the IoT M2M Council. My name is Keith Kreicher. I'm the Executive Director of the IMC, and we've got a great pair of speakers today, and I'll be introducing them in just a moment. But first, I'd like to take 2 minutes to introduce the IMC for those on the call that may not know us. The IMC started in 2014 when a fairly eclectic group of IoT solutions providers, combination of big telcos, MVNOs, providers of hardware and software, got together to form a trade association for the IoT sector. The group consensus pretty much from the start was that we did not want to be a technical standards body nor a testbed organization. Plenty of good people working on those issues, and they are important, but we see those groups as essentially vendors talking amongst themselves. We wanted to learn more about people that buy IoT stuff. And by that I mean enterprise users, product makers and designers, apps developers that buy connectivity, hardware, and software to connect devices in the field. What did these people look like? What did they need? How could we help them? We started putting out content. Pretty much anything we could get our hands on, white papers, use cases, blogs, newsletters. And we didn't ask people that wanted access to the content to pay us anything, but we did ask them to self-identify as buyers, not sellers, to join our organization as adopter members, to give us permission to talk to them, and crucially, to give us fairly extensive tabulatable demographic information. That whole effort turned out to be much more successful than we could have hoped. The IMC today has 25,000 rank-and-file adopter members, all qualified from around the globe, covering 24 different vertical markets, everything from automotive manufacturing to building and construction to retail point of sale. We get 300 new members weekly. They come to us inbound. We don't recruit. We do curate our member roles to keep them at around 25,000. And we do consider our adopter membership roles to be the largest market segmentation study ever conducted for the IoT sector. And the IMC board, our sustaining members now include some of the largest companies in the industry, AWS, HPE, Tata, Vodafone, but also smaller influential solutions providers. We see ourselves as an IoT accelerator. Our mission is bringing together buyers and sellers to expand the adoption of IoT technology. In that capacity, we're also the exclusive IoT partner for the Consumer Electronics Show and the exclusive IIoT partner for Hannover Messe, the world's largest electronics and manufacturing shows, respectively. We look at today's webinar on industrial IoT and edge intelligence as exactly in keeping with our mission. And with that, I will introduce our speakers, starting with Todd Edmonds, Director of Industrial IoT and Edge Strategy at Dell Technologies, where he has global responsibility for digital manufacturing and smart factory business development and partner alliances. Todd's an industry expert with 20 years plus experience in Industry 4.0, industrial IoT and edge computing, having worked for Cisco and Rockwell, among others, prior to Dell. Todd currently chairs the Edge Computing Task Group for the Industrial Internet Consortium, and he's a member of the newly formed Digital Twin Consortium. Todd, welcome and good morning.
Good morning. Thanks so much, Keith. Thanks for having us. Glad to be here.
Thank you. Also joining us this morning as a speaker is Fred Yentz, President of Strategic Partnerships at Telit. Fred joined ILS Technology, which is a Telit company, as Senior VP and COO in January 2007. At that time, he brought more than 20 years of industry experience in the technology solutions market. Prior to ILS, Fred was VP and General Manager at Radisys Corporation, a leading provider of embedded solutions, where he served in many senior management capacities. Fred also worked for IBM in various positions in engineering, new business development, and management. Welcome and good morning, Fred.
Good morning, Keith. Thanks.
I'm going to toss off to Todd in just a second, but before I do, I'd just like to reemphasize that we do encourage all of you in the audience to submit questions during the presentations. We will address these at the end of the session because we do like the entire audience to hear the Q&A. If we don't get to your question, never fear. We will have a record of it associated with your registration, which our speakers can and will address after the event. And with that, I pass to Todd Edmonds. Todd, take us away.
Great. Thanks so much, Keith. Hello, everyone. Thanks for being here. Thanks for joining us. Edge intelligence and edge compute has really come to the forefront when we start talking about industrial IoT and smart factories and Industry 4.0. And so with this partnership that Telit and Dell Technologies has formed, we think we have a really good capability to help you in your journey to implement these industrial IoT initiatives and help you with that industrial edge intelligence. A lot of people talk about what is the edge, where's the edge, what can the edge do for me, and we're seeing from our customers that edge can do so many different things, and we'll talk about what different edges and where that is, and we'll also talk about really how this solution and this partnership with Telit has two different sides to it. We call it connected products and connected assets and connected sites, as well as a connected factory. So when we talk about the edge can give you a lot of advantages. So more value, be able to remotely analyze data, improving safety from sensing and acting on data from autonomous devices, reducing costs, limiting and aggregating data instead of sending everything to the cloud all at once, and increasing the security to process that data and reducing the attack vectors, and also implementing faster decision at that edge. So we're seeing this across the industry where people are really embracing this industrial and enterprise edge, and we'll talk a little bit about what that is. When we talk about a manufacturing plant, when we talk about industrial plants, sometimes we talk about how to bridge that gap that exists from the information technology side, the IT groups, and the operational technology side, the OT groups. They have pretty much very differing priorities, and they go about things quite differently. But we see that this edge can really start to unite those two differing perspectives and be able to have the smart factory and unite those two enterprise and industrial edge. And so from a Dell Technologies point of view, where are we focused and where do we play in this industry? If you look at a typical industrial IoT implementation, you've got multiple levels. You've got some sort of edge compute down at the very bottom that's ingesting and connecting to devices and sensors and controls that don't give up their information very easily. That data gets passed up to some sort of local on-prem compute stack, whether that's a lot of times it's a computer that's sitting underneath someone's desk on the plant floor or a couple of servers sitting in a closet somewhere. And then that data then can get passed up to the enterprise core or the enterprise data center, and then sometimes onto the cloud. Not all the time, but a lot of times manufacturers are worried about sending that data to the cloud, and sometimes we can bypass some of these layers. But in general, this is what it looks like from most industrial IoT implementations, and the multiple edges are at that. Speaking of those multiple edges, this is where we identify the different edges for manufacturing. The industrial edge is that down and dirty, the gritty, hardened, industrialized devices that need to go on the plant floor and withstand the higher temperatures and vibrations, as well as the enterprise edge to aggregate and do some analytics on that data that are coming from that industrial edge. And this is an edge that is typically on-prem in a manufacturing facility. And this is where a lot of these industrial edge intelligence can be applied. And this is where the solution that we have with Telit can actually bring a lot of value to your clients and to your factories themselves. So to talk about a little bit about where we're partnered together, I'm going to turn it over to my co-presenter, Fred, and let him take it from here.
Sure, Todd. I'm going to go through and finish up building a couple slides, and you can see all the different solutions and applications there. So Telit, in the software that we're exploiting here together, can run at both the industrial edge side as well and the enterprise edge from a location point of view, where the applications are running. But I want to jump back a little bit and talk a little bit more about kind of where Telit plays in the entire IoT space, industrial and non-industrial. So most of you may know of Telit as a communications and hardware company. We're enabling thousands and thousands of companies that create connected products, connected services in the IoT realm. We offer things like connectivity plans, and you'll see some of these come into play when we talk about some of these solution bundles a little later today. But most of the content today is going to be really focused on our software and platforms. That's where our edge software, which we call the DeviceWise gateway software, and our platforms really come into play. So it's a pleasure to be here, and quite frankly, I want to thank the IMC for a couple things. One, they focused on the commercial attributes in making buying, sourcing, and services around IoT simpler with their membership and some of their work studies. So while this presentation is going to seem somewhat technical at times, it's also about showing you how the partnership is making this easier for companies and enterprises to acquire and use the technology. So with that, I'd love to think about what is needed at the industrial edge. Why? Why does this matter? The real world that we talk to in industrial spaces is not a greenfield world. These factories, plant sites, and machines have a variety of vintages. Some are old, some are new, but they're the real thing. This is where the rubber meets the road in industrial IoT. We have to be able to talk to them. We have to be able to ingest real-time data from these assets and be able to transform that data, whether it's through business rules, edge logic, data transformation, filtering, alarms and events. And then we have to do something with it. Industrial IoT and this entire digital transformation space that we're working in needs this new edge data brought up to where it's actionable. So where it's actionable tends to really rely on applications and services closer to the enterprise side. So being able to move that information not just to your systems of record or your IT services of record, maybe your SAP on-prem or or other services that you might be having running in the factory, MRP or ERP, but also out into the cloud space. Maybe you want to do some advanced ML or artificial intelligence or big data services, and you're going to rely on one of your cognitive cloud partners. Most important, I think, it has to be easy to deploy, easy to manage, and easy to buy, right? And hopefully we bring you some of that message in here today. There's nothing more important that's been more relevant to all of us in the last 3 months than the opportunity and the requirement to work remote. With COVID and the state of the world today, we're not really allowed to travel to many of our customers' factories, service machines that might be installed. So being able to reach assets remotely and take advantage of some of the remote services that becomes a byproduct really of this Industry 4.0 and intelligent edge is important. So net, we don't know where the world's going to go. We don't know what services we're going to need tomorrow, but flexibility. We need to be future-proof. We need to be flexible, and I think we can demonstrate a substantial amount of that flexibility later as we go through the presentation. I want to jump a little deeper when we talk about the edge, and Todd did a great job breaking it into kind of two pieces, the industrial side and the enterprise side. But everybody asks, where is the edge? And I love the concept that it really depends on your point of view. If you're a cloud company, if you're a big cloud data center company, AWS or Microsoft or a Google, pretty much anything not in the cloud sometimes becomes the edge. But if you're a PLC and a controls guy, maybe the edge is the sensor. Maybe the edge is actually the control systems, the PLCs and the automation technology that's at the edge. And being able to interconnect all of these elements with services is important. You stack on SCADA in the what we'll call kind of a level 2 version of the edge. And again, you're moving data between different services. Everybody in the factory is probably running on some sort of a manufacturing execution system, and that would be frequently considered the edge if you're at the enterprise headquarters side of an enterprise. And then finally, you've got kind of that ERP and that the MRP, more application side of the edge. So in between, the ability to interconnect all of these areas is important. So when we're talking about the edge, we want to be adaptive and responsive to what the customer is really thinking about. So if I had to draw a box around where could the edge be defined, it's really this entire stack. And I think Todd did a great job, really breaking it down, saying, listen, there's an industrial side of the edge and there's an enterprise side of the edge. And quite frankly, they're very different. Look at a factory. A factory tends to be an integrated set of networks all under management by one organization. And a factory will frequently have level 0 to level 4 in their control on their premise. But when we take a peek at connected machines or connected sites, we see a break in this network. We have an industrial edge that will always be present in these remote machines, remote sites. This is the controls layer, the supervisory, maybe some data acquisition tools. But the IT, the enterprise side IT never existed, these edge points. They're going to go back to some type of a headquarters environment or some type of a service layer that's going to be centralized. So when we talk about the edge, I think it's really important that we think about what matters. When we talk about connecting to real OT technologies, there's an element of that that's very important in a factory. And when we talk about integrating to the enterprise side, there's also a very important element of that at the factory. But when we take a peek at the connected machine model, they're broken apart. These two types of services, servicing the southbound side or the OT side and servicing the northbound side or the IT and cloud side, have a disconnect between them. And that disconnect is frequently solved by a variety of networking technologies, Here's where Telit plays substantially in delivering, wireless and cellular technologies to bridge unique networks. The southbound side of all of these OT connections, they might be packaging machines running in a variety of different consumer goods technology companies or consumer good manufacturing companies. Those machines are running in their network on their production floor. What we need to do is bridge away from that production floor into the maker of the machine in their IT department to make sure that we're providing them things like consumable reports and fault detection and allowing them to deliver an SLA that's very, very powerful. But this gap between level 2 and level 3 is something that we have to be aware of and address. So when we look at the differences, and maybe the title of this slide should be called What's Similar Between Factory and Machine Models. And what's similar is the idea of connecting to the devices, the enterprise edge, being able to do that atomic or autonomous filtering, analytics at the edge, decision-making at the edge, collection of data, and then transmitting it northbound. So the handoff northbound, whether it's to a system of record like your on-prem ERP system inside a factory, or whether it's through this cloud doing data delivery and managing the devices and doing the connectivity management and delivering it to some actionable service in a centralized location, those two elements can be very, very different. But the southbound piece, the industrial edge, is very, very common. And this is where we want to talk about the services that we're collaborating with Dell. The device-wise software, this is not a hardware pack, this is software. The device-wise enterprise gateway and asset gateway software really acts as this edge solution. And it's a no-code solution. There are a lot of companies that give you toolboxes to create some of these services. This is a no-code option. You load it in and you configure it to do what you need to do. And it's really broken into 3 layers. The southbound layer here, or this device access layer, is where we have all of the driver technologies. As we said, we need to talk to the real world stuff. The real world is where PLCs, ECS control systems, elevator controllers, building controllers, HVAC systems. There's a variety of assets that are out there that we need to talk to. And these are native drivers over years and years of experience that have been built to be able to connect to the real world. The middle section, or the true intelligence component of this, is where you need to be able to act upon these streams of data. And we love taking and creating value at the edge to create alarms and events or take action. Because everything in this, as you see the little arrow in the middle, everything is bidirectional in this stack. So we can take action if there's an alarm and event. Maybe we want to turn on some type of alarm on the machine, or maybe we want to send an email out or send some sort of a notification. Being able to look at time series data, looking at expression parsing, math, decisions, logic, these are all things that can be done very easily at the edge by configuring this toolbox. And then at the top, if you want to access the enterprise layer, this is where our enterprise gateway comes into play. And this is just another layer in the solution where you can reach to your systems of record, right? Whether it's an SAP system, an Oracle system, an IBM system, maybe it's IBM Maximo, or it's SAP PM, or it's Microsoft Dynamics and other solutions that are on the plant enterprise side. We have the ability to do that. But more importantly, I think not only deliver data there, but allow people to bridge to the next version, the next world, which is maybe these cloud solutions. And device-wise can run, whether it's at the edge in a small package, a small compute environment, or it can run up in the stack in a higher compute environment. It just really depends on how the customer wants to manage their architecture. So when we look at a combined solution, and I'm going to focus on kind of the machine side, and I'll let Todd take the factory component. But at the machine side, what we've done is we're bundling a solution where we've got the device-wise asset gateway software merged and bundled with the Dell gateway technologies, allowing us to collect and manage all the data in these machines or these sites, build them so that we can transport that data to some cloud service. In this case, we're showing that can go to any and all of them. The publish of the data doesn't need to go through the orchestration layer. We do have a service which we call our device-wise gateway management tool, which is our IoT portal, which allows you to deploy, manage, do device management of all of these gateways, potentially push down different rules or acquisition schemas as you're managed the life cycle of this. But this is a very, very simple way to look. No matter if you have 1, 2, 3, or hundreds or even thousands of machines, each of these connected machines may be in a different network or may be completely detached. So when we look at how this makes sense, it's about the buying opportunity as well. Not only have we created some great technologies on both sides and put them together, but we've created through this relationship with Dell the opportunity for customers to be able to purchase these bundles directly from Dell. Most enterprise customers in the world have a approved vendor relationship with Dell. So this gives them a very easy on-ramp to be able to buy this bundle. And if they were to need connectivity plans or something else, additional services are indeed available from Telit. So, when we look at the bundle, it makes sense. We've got many of these solutions deployed in use cases and reference cases, but more importantly, it's making it easy for new customers to onboard. So if you're a seller on the phone, maybe you're a buyer, maybe you're an enterprise customer, but we also have sellers here. We think about targeting the machine builder market, and these are companies that build machines that are either of high value, they're expensive, or they're complex, and they're delivering great value to the customers. If they have a global customer base or a very widely distributed customer base, that's important because they can't travel to go fix these. They can't service these machines. Actively monitoring, that's very important. And it allows machine builders to create unique models like performance-based SLAs that give them an opportunity to take their support centers and turn them potentially into higher-level profit centers. And it gives your customers the opportunity to count on performance, to count on making sure that widgets are being made at a certain rate because their machines are being monitored actively by the maker of the machine. And finally, I think it's important when you're targeting companies, when you're looking at companies, you want to make sure you've got a welcoming environment, whether they're looking at how do I enhance maybe my consumables replenishment. I mentioned packaging machines earlier. Some packaging machine makers also sell the supplies that make the packaging, whether it's the board and the bond, et cetera. They want to know when usage is coming up. So tying it into the business side, not just the maintenance side of the machine, is important. And ultimately, you want a management team that really is excited about embracing digital transformation. So it's an exciting time to enable machine builders and sites and remote assets to get connected. And it's an exciting time to show how easy this can be done through the combination of Dell and Telit. And with that, I'll turn it over to Todd to really talk a little bit more about the connected factory space.
Excellent. Thank you, Fred. So, this is all great stuff, and it's all great from that machine builder, that connected sites, connected machine sites. How would you deploy this at scale in a factory? And if you have customers or you're working in a factory, you know that there's some really high-level use cases. There's some really great use cases that have been that really have defined this industrial IoT initiatives across this industry that will really give you a pretty good return on investment right away. Production optimization, measuring overall equipment effectiveness, or OEE, doing some predictive maintenance, preventing downtime during the production run, doing supply chain, connecting that supply chain, optimizing your yield, as well as doing some connected worker initiatives. But one of the biggest challenges, or a lot of the biggest challenges, are that OT to IT convergence. How do you talk to the OT people, and how do you connect into those devices down on the plant floor and keep that from interfering with the production? So that's where you get the IT people and the OT, the factory people, at odds. how do you get past that proof of concept that really goes nowhere? How do you get that solution that can then really scale inside the factory and not just do a onesie, twosie, sometimes people like to call them snowflake implementations that melt quickly? How do you connect into those plant assets that are really not designed to give up their data very easily, that are designed to be islands of automation and do that automation and control very, very well, but not necessarily share that data with anything else to be able to do those use cases that we talk about? And that's where we came together with Telit and Dell, in that when you have these connectivity problems like protocol conversion, lots of legacy assets on the plant floor, what is the context of that data? What if you've got some older operating systems down on the plant floor that are insecure, that you don't really want to connect into your secure network? What if you want to do some AI and analytics at the edge? And what if you have devices that are overloading the network with the bandwidth required to just collect and push data, all of the data from every single, say, on a robot arm that you're trying to figure out predictive maintenance, and instead of just pushing all of the data from the sensors on that, you want to limit that bandwidth and just get interesting information and extracting data from a PLC, for example. So this is where industrial edge compute comes in, is to be able to connect to those devices and extract the data, reduce that data, do some local processing on it, add some context to that data as well as do some of those higher level protocol conversions that are necessary at the edge. At that point, then, what we bring in the enterprise edge to be able to aggregate that data and be able to do some interesting things with that data instead of just collecting it and dumping it into a database. And that's where this solution with Dell Technologies and Telit comes into play. With Dell Technologies and the DeviceWise software package, you can easily deploy the DeviceWise asset gateway down to the edge, down to those edge compute devices, and extract that data, format that data at will, and easily manage and control what it's connected to, and then push that data up to a centralized location, not only to just store that data, but be able then to connect into really any industrial cloud, any on-prem database. And we know in manufacturing applications, you really need to have a hybrid cloud approach. Some data can go to the cloud, some data needs to stay on-prem. And with DeviceWise running on the Dell hyper-converged infrastructure, that's where this can really come into play and make it really easy to connect to those devices on the plant floor, aggregate the data, and push it to wherever it's needed. So it makes it really easy to connect, extract, translate, and analyze that difficult to reach plant floor asset data. Makes it almost simple. This is what it looks like from a little higher level architecture point of view, is that Dell and Telit DeviceWise solution software bundle running on any one of the industrial infrastructure pieces that Dell Technologies has, from individual servers or even a complete hyper-converged infrastructure that can handle the data, that can handle the storage, software-defined compute, networking, and put that all together in a much more easily deployed, much more scalable package. And again, this is available through Dell. The software package is available through Dell. This is what it looks like. Build your own, choose your own infrastructure. We can put together a scalable solution that's right for your particular solution situation, whether it's a server or whether it's a hyper-converged infrastructure, as well as the software platform to solve your most difficult smart factory industrial IoT challenges. So the targets for this, really any organization that's embracing Industry 4.0 or smart factories, smart manufacturing, industrial IoT, and there's so many different names for it, but people that need to be able to have a scalable, repeatable, enterprise-grade way of connecting to those plant floor assets, gathering that data, and processing that data. So typically these are larger plants with multiple industrial assets. They're global manufacturers wanting to repeat this solution and make it very easy to deploy across the globe, across all of their factories. And system integrators, whether they're global system integrators or local system integrators, these are the type of people that are embracing this solution to make it easy to get that plant floor data, as well as the global solution provider. So we talk to a lot of we call them GSIs, global solution integrators, and most of these integrators have a very big, large picture of what they can do for a manufacturing plant, and high-level AI and machine learning and analytics and predictive maintenance. And they usually have a little box down at the bottom that says plant floor data. That's a really hard thing to do, is get that plant floor data and get quality data from that plant floor. This is exactly where this is targeted, is to be able to get that plant floor data and do those higher level business focused applications on top of that data. So a little bit more about the Dell portfolio, from the industrial edge to the enterprise edge. Dell Technologies has got you covered from tablets and laptops and workstations that are industrial hardened to ruggedized servers, embedded PCs and gateways, as well as everything all the way up to industrial grade hyperconverged, ruggedized server storage and other hyperconverged solutions. Add to that the global reach and support that Dell Technologies can provide. This makes it a winning combination for both Telit and for Dell Technologies and for your smart factory industrial IoT implementation. So with that, I've seen a couple of questions come in. Keith, I don't know if you've created some of those, but
yeah, thanks so much. First of all, Todd and Fred, really interesting stuff. I personally learned a lot and love the subject of the conversion of OT and IT. It's really where we live. I do have a bunch of questions here and want to dive right in if you guys are finished. So,
absolutely.
Let's start with how the partnership between Dell and Telit works. Is DeviceWise available through Dell at this point?
You can take that, Todd. Yeah. Okay, go ahead. You're going to take it, Fred? Yeah.
Go ahead.
It is available. It is available through Dell. It's on our price list. It's SKU'd up and ready for ordering. Whether you're looking at individual smart factory or smart machines in site, or whether you're looking at an entire factory-based implementation with distributed edge compute and connectivity to cloud and on-prem databases and everything in between.
Right. All right. And is the Dell hardware, is that specific to DeviceWise? Talk to us about that. How does it? I'm assuming Dell hardware works with other devices as well, but talk to us a little bit about that, Todd.
Yeah, absolutely. Dell Technologies has always been focused 100% on providing the best infrastructure, hardware, and applications for infrastructure that there are. Michael Dell's been very clear about that. We don't compete with a lot of our partners. We provide the best infrastructure that is open to anyone. So we 100% support open architectures, and open applications. So it's if you want to call it generic edge compute, but it's some of the best infrastructure there is.
Right. And what specific hardware does Dell have for the edge? I'm talking levels 0 and 1 in your presentations.
Yeah, sure. We've got an entire line of hardened edge compute devices. We call them, there are two different series. There's Gateway series, and then there's also Embedded PC series. that are industrial hardened, ready to be deployed on the factory floor, with everything from an Atom-based dual core to an i7 quad core processor capabilities and everything in between.
Right.
I think it's important to talk about also is some of the assets at the edge that you have also has some digital and analog input points, so you can actually talk directly to some two-wire sensors and things like that right at the edge. So this is while it doesn't really run at level 0, it can talk to like level 0 sensors as required.
Right. Getting a lot of questions on protocols. There's been obviously the presentation covered levels 0 through 4 at the edge. Are these broadly accepted industry definitions? And what kind of protocols come into play here?
Yeah, so for sure, it's a definition that makes sense, and it's been around a long time. It originally was referred to as the Purdue reference architecture model. So the Purdue model, you can look it up if you've never heard of it. And there is segregation. And originally the Purdue model was built so that things would pass from level to level to level. And from that point of view, I think it's a relatively stable and well-known space. In the kind of industry 4.0 space and in this world, we're trying to be able to move information from any specific level to any specific level as required. Now, that's not to say it's done without the right controls. So the device-wise agent that's running down at the south side of this has the ability to provide what I'll call user-defined permissions and roles, so you can only have access and only do functions as your permissions allow. So, we would never allow, for example, an IT person to go down and affect an action at level 1 or 0. They might be able to read a data point or read a value or read a KPI, but they wouldn't necessarily be able to control southbound. Likewise, an OT person running at the SCADA layer wouldn't be able to go up and affect something at the IT layer. They might be able to send data as requested, but there's got to be the right security and elements of safety built into this, and those elements have all been taken advantage of and addressed by the device-wise gateway software. That's a great question.
I would add as well is that one of the things that Dell Technologies, and I mentioned it quite a bit in my presentation about hyper-converged infrastructure, which is the joining of compute, storage, and network into a combined infrastructure that's software-defined and easily modified just using a software interface that really helps that to move that data from that layer 0 to 1, 2, 3, and on up through the infrastructure up to the enterprise level, share that data much easier, much more securely, that instead of having to do keep everything firewalled between every single layer. That's where we're really focused from the Dell Technologies, and the industry is heading, is that software-defined infrastructure to make that much easier to manage.
And are there standard protocols, Todd, for shop floor communications to the higher levels? And which OSI levels are covered?
Yeah, so that's one of the challenges at the plant floor, right? At that layer 0, 1, there are literally hundreds of different protocols that are a lot of them that are legacy protocols, a lot of them that are obsolete serial protocols, Modbus. I'm just blanking on them, but there's hundreds of them at that plant floor level. That's where the distributed edge compute can help, is to connect and ingest those obsolete protocols and then convert them into something that's Ethernet based, that's easily consumed at that enterprise edge level. So, and whether those protocols are the always on protocol, whether that's the MQTT protocol. I saw a question about that. There are multiple different protocols that can be supported. Telit has their own device-wise has a protocol that they use, but it's not limited to that, right? The beauty of the device-wise platform is you get to choose what protocol, what database, how you send it, where you send it. It does have a capability of taking that PLC data, ingesting and pushing that via MQTT, onto a message bus infrastructure. strategy, and so it's very flexible. But the key is to take those obsolete or really challenging OT protocols at the bottom layer, and then push them into whatever protocol you're really using at the upper layers in the enterprise.
Let me jump in a little bit on that one. So these are great questions, by the way. I'm thrilled by the number and the style that are coming in. But the protocol southbound, there's a specific question: do I need an agent or something special to run in these PLCs, these RTUs, these other devices? And the answer is absolutely not. We have 20 plus years invested in authoring on-the-wire native protocols. So device-wise adapts to your assets on the plant floor. So we'll speak all the native Rockwell, Siemens, Emerson, ABB, Fanuc, NC machines, all the different Modbus devices are supported. There's just so many protocols that are on the wire. And because it's on the wire, there's no limitation to speed. We can sample at a very fast rate, or we can take unsolicited messages in real time. So this is really, really great if you need to put this intelligent edge layer on top of your existing assets. And that's why we say disrupting the edge. We can come into a very old or a very new factory and immediately attach to the assets you have there, transform that data, and send that information for action, whether you're going into a BAPI in SAP, whether you're doing an MQTT topic publish, whether you're doing a direct insert into a Microsoft Azure Cloud or into Hub in the AWS. It's the any-to-any gateway for connecting the IoT layer to the IT layer at real-time speeds with an enormous amount of intelligence at the edge in a no-code space. So configure it, don't code it. OT guys don't like compilers. OT guys like to configure, and that's how this solution was built. And commercializing it with Dell to hit the masses is, I think, the sweet spot for this combo.
It also will. Let me add that it also has the ability to add context to the data at the edge. So it's not just numbers coming out of a PLC. You can actually map it to a data model that creates and actually add context to that data. Reduce the data, only pull data, and send data that's interesting, that's valuable to what it is that you're trying to do at the higher levels.
Yeah. Yeah, you're in it, and there's so much intelligence and bi-directional nature of all of these that you can even run in an atomic model. In the event you don't have the network connection, let's say you're a remote machine or a remote site, and you, for whatever reason, don't have that WAN or that wireless connection, or maybe you only want to the machine in the evenings or once a week. You can take actions, you can do context and actions at the edge in a very atomic way, or it can be real-time streaming up to the enterprise. And it's really about kind of the economics. You don't want to be pushing on good data every 50 milliseconds, chewing up the data plan. You might want to send a status daily, but you want to send an immediate announcement if there's ever a problem asynchronously. And device-wise can be configured to do either of those, which I think is the beauty of that in a no-code way.
Yeah, at whatever frequency that you want, even like down to the millisecond level.
Right up. Also getting a lot of questions about security, and I think you guys answered the first part of this, and that is, what security model are you proposing? The Purdue model typically isolates lower levels, preventing two-way communications for provisioning and management at the edge. What is the security model functional here?
So there's a very robust user and security model environment built right into the device-wise gateway. So you can define users, define their actions. You can define what tags they see, what machines or services they see, whether they can read or write. if they're not provided access to those services, they're not even exposed to that user when they see the workbench. There's also, it's not just about security, it's being enterprise grade, which means supporting things like exception logs, administration logs. If you're doing activity in food and beverage or drug pharma, you need to have, 21 CFR 165. I don't even know all the numbers, but there's these standards around traceability and monitoring. We have the support to achieve those because an administrator goes in and maybe changes a set point to allow a bad actor to do something, and then the administrator changes it back. That would all be logged in the log files and the exception logs. So there's a kind of a truth detector, if you will, built right into the device-wise at the edge in a very atomic way so that these types of processes can be documented, audited, and managed. So it's not just acting as a secure actor there, but it's ensuring that that actor's been secure through the audit logs, et cetera. So it's enterprise grade in every aspect.
And I'll also add, if you mind, that from an infrastructure and an architecture point of view, we absolutely can support the Purdue model and the multiple layers and firewalling in between. But we also support the hyper-converged infrastructure so that you can do things like micro-segmentation down to that edge level so that if there's any bad actors that get in at that one layer, typically at that one level, typically they can go east to west with impunity at that time, where micro-segmentation can prevent that kind of actor. So you segment every single one of them so that east-west is not a possibility as well.
And will that HCI run on virtualized infrastructure?
Absolutely. Virtualization is a key component of HCI. So virtualizing the workloads, but also virtualizing really it comes down to virtualizing the entire data center. So having virtualized storage, virtualized compute, and virtualized workloads, and as well as networking is part of that key feature to the hyper-converged infrastructure.
Right. Jumping back to security for a second, I've got a question here on zero trust, a phrase I'm familiar with. How does that apply within the security model?
Boy, I'm going to have to defer. I don't know, Fred. Fred, are you familiar with zero trust?
I don't want to misspeak. I'm not exactly sure what the question means, but we'll have our chief security officer and we'll respond to you online on that one.
Right. So we can get back to him with the answer to that. You guys have certainly answered this question, but I just want to confirm that the solutions proposed do in fact allow the connection of legacy PLCs on the factory floor. That is one of the big advantages of the solutions as proposed, is it not?
Absolutely. That's exactly right. And I know, I'm sure Fred can speak to this a little bit more. And if there's a really broad range of devices that are built into DeviceWise and have that connectivity. If there's something that needs to be added, there is. Correct me if I'm wrong, Fred, but there's a SDK to help develop those drivers for some one-off type devices.
For sure, yeah, it's exceptionally extensible. So there is an SDK you can develop your own drivers. We will also develop drivers on your behalf, but this has been around for so long through development and organic development, through licensing and OEM relationships with many of the OT vendors. With folks like Mitsubishi and we've worked collaboratively for decades. You'll see these drivers that you need probably already exist. One thing that's actually very interesting, you take a very common driver, like a Modbus driver. we will code, or you can code not just to the Modbus, but you can code to your device, so you can expose exactly the tags you want to expose, so it eases deployment and configuration for the OT person in your world. You're not worried about things like Modbus offsets and things you would normally do if you're looking at it through sort of the generic simple standards optics of Modbus. We make it usable. We want to get to a point, click, and configure environment, because that's how you make deployments work quickly. We're in about 7 of the top 10 auto OEMs. We're in a pile of the tier 1 suppliers, and they're using it because the training ramp is quick, and they can use this layer of edge independent of their control vendors' choices, because nobody is 100% monolithic on the plant floor. Many people have Rockwell and Siemens, and they have Mitsubishi here, and they might have CNCs and RFID readers from different vendors. So there's no such thing as a homogeneous plant floor. Everything is very heterogeneous, and it's a tool that allows you to talk to all of those different things with one common tool. So it eases training, it quickens deployment, and it simplifies the sustaining attributes of these solutions. Because in the old days, they were a lot of hand-coded, a lot of glue code, and when workers retired, you had a tremendous challenge sometimes supporting these homegrown solutions in the factory.
Right. You mentioned automotive, Fred. Are there other verticals for which these solutions are best suited? Can you talk to us about that?
You know what? Great question. So it's a horizontal platform. It's a horizontal solution. There's no specific vertical that it's built for. I will tell you that we can very easily exploit a lot of the discrete spaces. Many of these device types, PLCs and NC, torque tools and drivers are for discrete assembly and test kind of environments. But we also have a tremendous deployment in things like pharmaceutical, batch process, oil and gas. We're in a variety of the industrials. And then when you pivot and you look at the connected machines, we're in everything from upstream oil and exploration to sites like water management, lift stations and utilities, smart city complexes. We're doing things across almost every imaginable vertical. But the flexibility is there, so it's really up to the imagination and the innovation of our customers.
Right. And I think you guys have touched on this, but more than touched on it. You've confirmed it, but just to confirm again, processed on these solutions at very high frequency, say every millisecond. That is a part of the purpose, is it not?
Speed is important, so we can ingest, at a variety of speeds, and we can accept real-time, unsolicited messages from these devices as they send them off. So, we really don't have issues around sampling or streaming.
And in addition, too, I mean, you can do edge intelligence to sample at a high frequency rate, but not necessarily put that on the network if it's not necessary, and just sample and do some logic at that edge to be able to decide if something does happen within that, that for sampling, then trigger an action or trigger pushing some of that data up, or even sort of storing that in a small database built into device-wise at the edge, and then pushing that up at a certain level. So you're actually doing bandwidth management as well. So you're not putting 10 millisecond or 1 millisecond data on the network unnecessarily.
Yeah, I call that kind of bandwidth economics. If you've got a good environment, send a message when there's a problem and send a status occasionally, and keep all of your chargeable network costs as low as you can. But don't ever sacrifice the real-time nature of the solution, and device-wise can be tuned to provide those services that way.
Right on. Well, we are literally at the hour right now, and with that, I would like to thank Todd Edmonds of Dell and Fred Yentz of Telit. Thanks so much, guys, for a great presentation. Like I said, I personally learned a lot and took some notes, and we'll try to digest those afterwards. But also thanks to everyone in our audience. We had a great turnout today, and we do appreciate everyone's time. Do wish everyone can stay safe and well, and please join us for our next webinar on July 16th. Thanks so much, one and all. Fred.
Thank you. Thanks, everyone. Thank you, Keith.
Thank you, guys. Appreciate it. Thank you, Todd. Great partnership. Let's make more customers happy.
Absolutely.
Cheers.